We are in 7.3. We are going to talk a lot more about these rational functions and graphing them, and they're going to get a little different than what we've done so far, but not too bad. We've definitely set up for success here. We've been doing everything from 7.1 to 7.2. 7.3 is just going to build off that. So first off, it says analyze the methods Jody, Teresa, and Jen use to graph each of the rationals. We're really going to focus on Jody and Teresa. We're not really going to focus in on Jen. Jody, if I was going to do a problem, I would do what Jody is doing. I think it's the best way. The way that she does it is, the first thing she does is she looks at this problem right here. And again, if we're going to graph something, we grab our vertical asymptotes, we grab our horizontal asymptotes, and then we make an X and Y chart and go from there. And so when she does this, she realizes, wait, this one right here, I've got a factor which can be factored to X plus 2, X minus 2, and she realizes that her vertical asymptotes are X equals 2 and X equals negative 2. And if you look down at her chart, right there, negative 2 is undefined and 2 is undefined. Why? Because they're vertical asymptotes. She also realizes that the bottom power is bigger than the top, so y equals 0 is an asymptote. So if you look at her graph right here, you can see there's one of the asymptotes, there's the other asymptote from right here and right here, and then she's got this horizontal asymptote that is the y equals 0. So there's those asymptotes that we found, and then what she does is she just picks numbers. Now, remember, we're just doing a sketch of this. For these guys right here, for these two ends, you just need to figure out 1 point, and I'm fine with that. Maybe 2 points because if they're asking you to graph it, you might want to do 2 points to get a little better picture of it. But I'm fine with just basically 1 point, as long as you remember these are eventually going to chase those asymptotes. So what you would do is you plug in a number that's on this side of the asymptote, which would be like a negative 3. So if you plug in negative 3, you plug in and you see what you get. Negative 3 squared is 9. 9 minus 4 is 5. 1/5 would be your answer, which is exactly what she got right here. And so you see that at negative 3 1/5, it would be negative 3 1/5. It's going to be really small right there. So that's why she got this graph to look like that. We understand that it's up. Now the next section, so you should see you have 3 sections. You have here, here, and here. We need to fill those 3 sections in with a graph. So I filled this section in with the one above. Now I need to figure out in this section, is it here or is it here? And the shape is going to be a U. How do I know it's going to be U? Because remember, it's eventually got to chase this asymptote. And it's got to chase this asymptote. And if it's in between those pinched, it's going to make a U shape. So I plug in a number in between there. What's the easiest number that you can plug in? To me, a 0 is the easiest number, because 0 squared is 0. 0 minus 4 is a negative 4, and a 1 over negative 4 is a negative 1/4, which is exactly what she got right here. Now with this guy, since it is a parabola that we're going to do, I would do at least 3 points like she did. You can see she did 3 points. So not only did she do 0, she also did negative 1, and she did 1. Those are very easy points to plug in. Negative 1 squared is 1. 1 minus 4 is negative 3, so she got negative 1/3. Right there. She just drew it a little bit lower, and it's not going to be real accurate because we're dealing with fractions. 1 squared is 1. 1 minus 4 is negative 3. Negative 1/3 also. And we know that that makes sense because this is my vertex, and I know that these 2 points, this one should mirror that one. So boom, she drew this. And then last, she needed to find this piece, and so what she did is she picked a number bigger than 2, and so she picked a 3. And if you notice, watch what happens. When she picks 3, 3 squared is 9. 9 minus 4 is 5. She got 1/5 again. Notice this guy right here and this guy right here are the same. Now, it doesn't always have to be 3 and 3. What it has to be is, you see how this 3 is 1 over from the asymptote, and this is always 1 over from the asymptote. Those guys are going to match up. So boom, she's got that drawn in. Again, all else fails, make an X and Y chart, pick some points, and boom, you can graph this. That's all you need. The biggest things are the vertical and horizontal asymptotes, because that's going to help dictate the shape of your graph, because we know the graph is going to chase those asymptotes. That's the way I would do this. That's the one I think is the most important. I'm going to explain Teresa's, but not going to do as much detail. What Teresa did is very good. She said that she graphed this, and the reason she graphed this is because these guys are inverses. Remember, if you multiply them, you get 1, which x squared minus 4 over 1 times 1 over x squared minus 4. These guys cancel out, which turns to a 1 and a 1, and so that all turns to a 1. So they are inverses of each other. So what she did, she graphed this guy. She graphed this, the parabola. She knew that the vertex was 0, negative 4. She knows that this moves, remember, vertex form, which this is in, says that it should be x minus 0 squared. And then she did minus 4, so she knew 0, 4 was her vertex. Boom. She then plotted some very important points. She knew that if she put a 0 in for x, if she said a 0 in for y, she knew that this would be x plus 2, x minus 2. She knew that the intercepts would be negative 2 and 2, because those make it 0. If you put a negative 2 in, that makes it 0. So negative 2, 0 is my x-intercept. She put in 2 here, which makes it 0, which is your other x-intercept. Those are key important points. And then she just plotted, she just put a 1 in, a negative 1 in, and got negative 3 out. She put a 1 in and also got a negative 3 out, because if you take 1 squared minus 4, you get 1 minus 4, which is 3. So her x and y chart would be 1, 3, negative 1, negative 3, negative 3, negative 3. So that's where she got these points. Now, since it's the inverse, she's going to take this point right here, and you're going to have the same x, but you're going to invert the y, which means it's going to become negative 3 is the same, comma, inverse of 5 is 1/5. And if you look, that's what she graphed right there. Try this one. Negative 1 stays the same. Invert this, which is a negative 1/3, which if you look, that's that point right there. She takes 0, 4, she inverts it. So it'd be 0, comma, not negative 4, but negative 1/4. If you look back at our chart, that's exactly the same point that we got right there. She takes this point right here and inverts it, and it becomes 1, comma, negative 1/3. And that right there is this point here. Finally, she inverted 3, 5, which turned into 3 and 1/5, and boom, got that right there. And the last thing that she knew was, because these were the intercepts, that's where it touches 0. You can't invert the 0. So if you try to invert the 0, we can do that. It becomes negative 2, comma, since this is 0 over 1, you can put that over 1. If you invert it, it becomes 1 over 0. Well, hopefully you go, uh-oh, you're not allowed to divide by 0. That's not a point. That's why we have a asymptote that's occurring there. Same with this one. You can take the 2 and invert the 0 over 1, which becomes 1 over 0. Not allowed to have that happen. So boom, she drew her asymptote. So that's kind of the explanation of what she was doing. So that's going to be key. That's what we're going to do. I'm going to do the first way for each one of these. I'm going to do these types of problems. We're going to go through a couple of these, then we're going to do some practice problems in class big time. This first one is fairly easy because they give me the vertical asymptotes right away. I know my vertical asymptotes. So my vertical asymptotes are x equals 2 and x equals negative 4. And I graph that. 4, 1, 2, 3, 4. And then I know my horizontal asymptote is going to be, my bottom is, actually this is x squared, because you've got x times x, so that's x squared. The top is x to 0, so bottom is bigger than top, which means y equals 0. So boom. got this asymptote. So I have 3 parts that I need to fill in. This part, and this part. And I know this is going to be one of those like shapes like this is going to be here and here. And I know in here, one of these spots is going to have to be a U either up or down. And I know this one can be here or here, this one can be here or here, and it's going to be this type of shape, just because that's what I've been seeing happen. So here we go. I need to make an X and Y chart real quick. What would be the easiest number to decide if this section over here, well, if this is -4, then I'm going to use -5. And I put that in. That means that this becomes a -5 right here. The X becomes a -5, the X becomes a -5. So here we go. -5, so we got 1 over -5 minus 2, -5 plus 4. So this becomes a -7, and this becomes a -1. So that becomes a positive 1/7. This negative and negative becomes a positive 7. You have 1 over 7, so 1/7. And again, they've asked me to sketch this, so I really don't have to get too detailed. All I care about is that it is a positive, which means my graph is in this section, not down here. So I know it's not down there. So I know my section is going to be like this. And then I'm just going to try this section over here, because I believe it's going to be up here. If this one's up, I believe this one's going to be up. So I'm going to try a number. If I tried... remember, if it's 1 over from the asymptote, it should be the same 1 over from the asymptote. So if my asymptote here is 2, then I'm going to plug in the number 3. And if I plug in 3, it should give me 1/7, just like the other one did. Remember, I'm 1 from the asymptote here, I'm 1 from the asymptote here. Those numbers should match up, and I try it. 1 over 3 minus 2, 3 plus 4. This equals 1 over 1 times 7, which equals 1 over 7. That's what I thought should happen. And again, that means that it's right here, and I've got that sketched. Now I need to figure out where this middle part is. So to figure out the middle part, and I need a couple more points of just 1, I'm going to try to figure out the middle part. So if I think about this, I know that this asymptote and this asymptote, in between here, in this section here, and in this section somewhere maybe here, either one of those, it has to be a U, which means it has to be a parabola. If it has to be a parabola, then the vertex has got to be in the middle between the -4 and the +2. It's got to be in the middle, because the vertex is even, remember, it mirrors it. So I know the vertex has to be in between this guy and this guy. So I know my vertex. I know the X should have to be -1. Why? Because if I go over -4, I go over 1, 2, 3. I go over 1, 2, 3. This line right here, that's the middle. So I know that's going to be, that line will be my vertex. So I'm going to use -1 to find my first point. -1 minus 2 is a -3. -1 plus 4 is a -3. Sorry, -1 plus 4 is a +3. And 1 over -9 is a -1/9. So I got -1/9. And I'm just going to do a couple more points just to make this, make sure I get it. -2. And then if I do -2, that's 1 point over, then I'm automatically going to have 0. Because remember, if I go over 1 this way, I know it's going to mirror over 1 this way. So I only have to do one of the points. Again, we're going to do some more practice on this tomorrow in class. So please just follow me a little bit, and hopefully we'll drive this home tomorrow. So again, I'm just plotting points. I'm going, okay, here we go. Put in -2. -2 is here, -2. So that becomes -2 minus 2 is a -4. negative 2 plus 4 is a positive 2. That becomes a negative 1/8. And I know that sounds weird, but a negative 1/8 is actually a little more negative. It's a little close, so it's actually down just a little bit from the 1/9. And if I try again, if I plug in a 0, which will help me out because they asked me for my y-intercept. And since they asked me for my y-intercept, what is my y-intercept is when x equals 0. So I'm getting that answer anyways because I'm plugging in a 0. I think it should be a negative 1/8 because remember it should be mirrored from this. I know this is my vertex. So I plug in 0. 0 minus negative 2 is a negative 2. 0 plus 4 is a 4. Negative 2 times a 4 is a negative 8. So I get negative 1/8, which is the same thing like I thought it should be. And remember, that's just going to be a little bit like this. And I know it's going to chase that asymptote. It's going to chase that asymptote. That's a quick sketch of what this graph should look like. If I fill in now my domain, does this thing ever stop going left? No, no, no. The only thing is it's not allowed to be this number right here, and it's not allowed to be this number right here. So I say it's all reals, except x is not allowed to equal a negative 4 or a 2. Now my range, it never stops going up, keeps going up. And this part actually keeps going down forever. So it's all reals, except it's not allowed to be y can't equal 0. All right. And then my y, it also asks me for my y-intercept. My y-intercept was x equals 0. So when x equals 0, my y-intercept was a negative 1/8. You can write that as 0, comma, negative 1/8. You can write it as just a negative 1/8 if I ask you for the y-intercept. Whichever way you want to put it, that's fine. All right, so all these problems down here are going to be the same. All of them are going to be the same process of what I did here. The only difference between any of these problems from what I've done is you're going to have to factor the bottom first. So this guy, so all I'm going to do is I'm going to practice the factoring part, and then I'm going to hope that you try to do these on your own, where you're going to do the same process that I did. You're going to make an x and y chart. You're going to find the vertexes or the asymptotes. Make an x and y chart, find out where these graphs are located, and just draw a sketch. Maybe I'll do one more with you. Let's go ahead and try, let's try C. Maybe I'll talk you through D. All right, here we go. So double bubble right away, because this is 1. 2 numbers that multiply to 10, but different signs subtract to 3. X, and it's the bigger numbers positive, plus 5, x minus 2. So my vertical asymptotes. So right away, that helps me out. I know that x cannot equal 5, negative 5. X cannot equal negative 5, and x cannot equal 2. Those are my asymptotes. Horizontal asymptote, yes there is, because the top is smaller than the bottom, y equals 0. So again, what I'm going to do, talk you through this problem. I don't think we should do all this problem out. 1, 2, 3, 4, 5, asymptote, 1, 2. I know that my x and y chart, one more vertex or asymptote is right here, y equals 0. So I know I'm going to have a place here, here, and here. I need to figure out up or down, up or down, up or down. So I pick a number. If I was going to do this, I would pick negative 6. And I'd plug in. I'm going to let you try that on your own. For my middle, since this is negative 5 and this is negative 2, I need to figure out what's the place in between them. So if you want to find, positive, if you want to find the number that's in between two numbers, you add them together and divide by 2. Negative 5 plus 2 divided by 2. So that would tell me that my vertex for this middle part of my parabola is going to be at negative 3 halves. So negative 1.5 is what I'm going to do to be my vertex for this middle one. And then I'm going to pick a couple other points in there. I would pick easy numbers that are around that. So I would actually pick negative 2, and I would also pick negative 1, and pick those numbers and plot them on there, figure out where this graph is. And last, over here, if this is 2, my next one would be 3, and 3 I know should match up with 6 because this is 1 away from the asymptote this way, this is 1 away from the asymptote this way. These guys should mirror each other because it's squared. Alright, this right here, if I was doing this problem, this part right here is not factorable. There is an asymptote, the vertical asymptote. If I plugged in, what would, if x is 1, if I put a 1 in here, 1 cubed is 1, 1 minus 1 is 0, not good. So x equals 1 is my vertical asymptote. So I go x equals 1. Horizontal asymptote, bottom's bigger than top, y equals 0. So I know it's odd. I know it's either going to be here and here, or it's going to be here and here, and I would just pick, I'd make an x and y chart, pick numbers, and I would pick 0 because that's the easiest one to find this side. I would pick 2 to find the other side, and boom, I draw a sketch of that. Alright, last couple things that we're going to go through. The function x 1 over x is shown in black on each of the coordinate plane. Determine whether the second function, which is in blue, is j of x, m of x, or k of x, and these are what these guys look like. So we're going to try to show what these do. Well, right here, if you remember, we said that if anything is outside of it, it moves it up and down. So if you remember the rules that I taught you, this is the part that's going to move it up and down. Notice I do this, and then I move up and down. And when I'm talking about up and down, that's going to shift my horizontal asymptote. So if I look down here, my horizontal asymptote is right there. My horizontal asymptote for this one is right there. Notice it has not been shifted. But when I come to this middle one, my horizontal asymptote has been shifted up 2. The whole graph, even including the horizontal asymptote, has been shifted up 2. So as soon as I see that, I know that this is k of x. For this guy, this one is going to be, if you remember my rules, this is the guy where it's like inside the parentheses, because if you remember, when you have a fraction, those are parentheses there, so it's inside. So it moves, this moves it right or left, and it's the opposite way you think, just like it's been the whole time. This moves up or down, and it moves it the way you think. So this guy moves it the opposite, this moves it the way you think. So if I think it's a +2, I think it goes right, but it actually goes to the left, and it's moving, if it's left and right, it's moving my vertical asymptotes. Well, look at this guy. You can see my vertical asymptote is no longer at 0 anymore, it's at -2, which means it moved it left 2. So that means that this function has to be the j at x. And then finally, what does this 2 do? It just makes this graph shoot up faster. It just changes you see this right here. You see how it's like that. The pitch of this, that 2 just changes kind of the pitch or the arc or the angle or whatever you want to call that. Just makes it a little bit farther out. So this has to be m of x. And we'll do some more examples like this in class and talk through that. Remember, write down questions if you have questions. So sketch this. If I know what this guy looks like, which I do, my regular one, since it's odd, I know it's going to be 1 up, 1 down. I know that there's a positive up here, so it's going to be start down and go finish up there. If this is +5, the +5, all that's going to do is shift this thing up 5, which changes not my vertical asymptote, but it changes my horizontal. So all I'm going to do is my vertical is going to still be the same. But instead of being vertical or horizontal asymptote at 0, it's going to be at 5. 1, 2, 3, 4, 5. And that's where my asymptote is going to be, and then boom, everything else is the same of this graph. That would be a quick sketch. Remember, if you can't figure that out, just make a x and y chart. And just remember, when this says f of x, when this says f of x, if I was plugging in, this f of x changes, I can put this in its place. This is called substitution. So really, g of x is equivalent to 1x plus 1 over x plus 5. All I did is I took the f of x out of its place, I took this out, and I put this in its place, because that's what substitution allows me to do. Bink! And so now I can see g of x is 1 over x plus 5. That moves it up or down. And then if I want to, like I said, you could just put some points in there. The easiest point for me to put in would be 1. And if I put a 1 in, 1 over 1 is 1. 1 plus 5 is 6. And then that makes sense. Look, I go over 1 up. Now instead of going over 1 up 1, went over 1 up 6, which puts it right in the section I thought it should be. If I put a negative 1, that becomes a 1 over negative 1. That's a negative 1. Negative 1 plus 5 is 4. Boom, which is right here, like I think it should, like I thought it should have been. This guy is inside parentheses. That means that it's going to move it the opposite way, and it should move everything to the left because it's inside parentheses 5. Now, here's what this means. This means you take, and where you have f of x, you look at f of x, which f of x is just 1 over x. You take, if h of x, really what this means is you take the f of x function, and instead of writing this x, you write what's in the parentheses. So what this becomes is not 1 over x, but 1 over x plus 5. And what do I know this should do? That should move my vertical asymptotes, and it moves it the opposite way I think, so it moves it back 1, 2, 3, 4, 5. And my horizontal asymptote is the same, and everything else is the same. It should be here, and it should be here, and I confirm that by making an x and y chart. So if this moved over 5, I'm going to not put in a negative 5, I'm going to put in a negative 6 to try it out. Negative 6 plus 5 is a negative 1. 1 over negative 1 is negative 1. Boom, negative 6, negative 1 in the section I thought. Try 1 to the right of it, not 5, but negative 4. Negative 4 plus 5 is 1. 1 over 1 is 1. Boom, in the section I thought it should be in. Remember, it's just quick sketches. Alright, I think that's good enough for tonight, and we'll finish the rest of these. We'll talk about some of these maybe tomorrow. Actually, I'm going to do at least this one. We're going to do A together. All you have to do is, if it says write a vertical asymptote at 2, that means 1, 2, you know it's moved to the right. Horizontal asymptote is at y equals 1. That means it's moved up. If you think about that, that means that I have something on the top, doesn't matter. My vertical asymptote has moved to the right too. So that means that down here I have to have x, and I have to have a plus 2. Sorry, not plus 2. Minus 2. Why? Because if I put a 2 in here, that makes the denominator 0, which means, nope, that doesn't work. That's not an asymptote. So that's where this information right here I used for making my denominator. Horizontal asymptote, it moved it up. Where does the up go? Out here, plus 1. Let's try again. Vertical asymptote at 1. So right there. Vertical asymptote at negative 5. Horizontal asymptote at negative 3. Okay, if I know that to be true, remember, this doesn't always have to be the same, but the top really doesn't matter too much to me right now. 10 over, what do I know? It has to be, the bottom has to be 0. So if this was what makes it 0, then the x minus 1 has to be in here, because if I pop a 1 in, 1 minus 1 is 0. If negative 5 is what makes it 0, then I have to put in a x plus 5. That takes care of all my vertical asymptotes. Now for my horizontal asymptote, if I want to move it down 3, then all I do is I put a minus 3 out here. Alright? These last ones, all you have to do is, if it's asking you for f of x, and it says, I want you g of x to look like this, where you're taking it and this moves it opposite way, this moves it up or down, left and right. So this actually moves it to the right too, is my vertical asymptote. This moves my horizontal asymptote down 4, so I know my picture is going to look like that. And it says it wants me to take it and just put it. So I'm taking this and putting this in the x, and minus 4, all it's going to become is 1 over, replace this with the x. So it becomes not x in the bottom, but x minus 2. And this minus 4 has to come back out here, because outside moves it up and down, which changes the horizontal. In the parentheses, moves it left and right, moves it left and right, opposite way, I think. All right? They want me to shift, they want me to do any one where I take g of x and I shift it up and to the left. Okay? So I need 1 over, now in order to shift it to the left, I have to do x plus some number. And I don't care what number you put in here, they don't either. You could put plus 3. And that would move it left 3, because remember, opposite way I think. And up means I need a plus number back here. Doesn't matter, whatever you want to put, 7. And that's it, guys. We'll practice this again some tomorrow. Hopefully it's making sense to you. I appreciate it. Hope you're watching these videos, guys. Have a great night.